Lesson 4.7, calculating higher derivatives. Higher derivatives just mean taking it steps further, like not just finding the first derivative, but then maybe finding the second or the third. And let's talk about notation. So now I can have f double prime of x. That would tell you to do the second derivative, or it might say d squared of y over dx squared. That's just a way to tell you what you're supposed to be doing. So we've got a function here. It looks kind of gross. This would be awful to do the old school difference quotient with. Good thing we now know the power rule. So I'll be taking -2/3 times the 3, x to the subtract 1 from the power be x squared. This is a 1, so we'll be taking 2/9, and then x minus to the first minus 1 would be gone, plus 6 times a third, x to the 5th, plus 4 times 1/6 x cubed. So my 3's can cancel. I end up with -2x squared plus 2/9. This can divide by 3. So that'd be 2 times 1 is 2, x to the 5th. This can simplify, take out a 2. So I get 2/3 x cubed. That's my first derivative. Now let's do it again. That's where it gets fun. 2 times -2 is -4, x to the first. The constant would be gone. 2 times 5 is 10, x to the 4th. 2/3 times a 3, the 3's would cancel to give me 2x squared. And if you leave it in this order, that's fine, or if it bugs you, you can put it from highest degree term down to the lowest. Third derivative is the same thing, it's just taking it one more step further. You might see f triple prime of x or d cubed y over dx cubed. Okay, so why don't you pause this one and see if you can get the same answer as me. My final answer, y triple prime, or if you like this notation better, I personally like always the little tick marks better. I got -18x minus x to the -4th power. So you can go back and see if you have any questions on any of that, and I can help you. And you can leave it x to the negative power unless you want to sink it down to the bottom, but Delta Math doesn't care which answer you put in.